Hi, we are Team 54 and we are presenting KGInPaint, an interactive dashboard to generate scene graphs for an input image and then inpaint it into the input image using the scene graphs itself. This is what our dashboard looks like when it's empty. You can see drag and drop or select image right here, so we can feed in its input image. Let's consider this stop sign for instance. So once I add it here, it takes a little time and generates a scene graph for it. You can see the scene graph has been presented here. So this is the scene graph that describes this particular image right here as well. So within the scene graph, say for example, you can select a node. So say if I want to select this one, I select the sign itself. So you can see the sign has been marked under this pink bounding box, which is the bounding box predicted after the scene graph generation process. So since this is highlighted in pink, we highlighted the corresponding bounding box in pink here on the image as well. What you can do more with the scene graph itself is that you can analyze the scene graph corresponding to the input image. So say for example, I can select this particular edge and I have this particular triplet that says window 53 window, 3 building has 53 window. So 3 building is highlighted in orange within the scene graph itself, and the corresponding bounding box for the building itself is highlighted in the image in orange, same as that of the node in the scene graph. And the window has been marked in purple. This is the window right here. So it has the triplet that the building has the window. This is the relationship described in this case. What more you can do is that you can select particular relationships that you want to highlight within the scene graph. So say for example, I want to highlight all the has type of relationships within the entire scene graph. So I can just select has, and this same all the triplets which have the relationship has have been highlighted in blue within the scene graph as well for the user. So same 3 building has 53 window. This has been highlighted in blue as well, and if you select it again, you can see it on the dashboard. These are the scene graph features that we present to the user, where the scene graph is generated for any given input image, and then based on these scene graphs you can inpaint within the app as well. So inpainting has been restricted to objects itself, so you can either remove an object or replace an object, and I'll show you how. So say I want to start with removing an object itself. So for removing an object, I will select a node within the scene graph. Say consider this letter for example. So these are the letters stop within the stop sign itself, and if I want to remove the stop letters from within the object itself, I select the node, and all I have to do is press on remove object. Once remove object is selected, you will see that the page is updating. This will take a little while since we run about 150 inference steps for the inpainting process itself, and before the inpainting process we run a segmentation task to segment out the letters from within the bounding box as well. So give it a few minutes and it will load out the inpainted images for you. I will speed this up in the video for your convenience. Okay, so the inpainting model has returned its results, and after removing the object, the inpainted output looks like this, where the letters stop have been removed from the stop sign itself. We present the user with 3 options for them to select from, and it is a carousel of 3 images that is displayed for the user itself. You can see these arrows right here and a few small tabs with which they can see all the images. So if you see that the output images are very similar in nature, so that's why all 3 of these images look same, but in all 3 of them the stop letters have been removed from the stop sign itself. This is one of the features where on selecting a node and clicking on remove object, the inpainted output removes the object itself. Now the next feature that we offer is replacing an object within the input image as well. So let's go back to the sign itself. So say what if I want to replace the sign with a soccer ball. So all I have to do is write down the prompt soccer ball here. This is passed on to the InPainting Hugging Face model as a prompt as well, and all you have to do is just write soccer ball in this prompt and click on replace object. On clicking replace object, you can see again the dashboard will take a little while to update itself as well, and I'll show you the output results for replacing an object as well. Okay, right now I've skipped to the point where the output has been generated from the input from the Hugging Face InPainting model, and the replace object results have been displayed here. So you can see the stop sign itself has been replaced by a soccer ball in this case. Again, similar to that of the remove object itself, we present the user with 3 possible outcomes. So again, here the soccer ball has replaced the stop sign, same as the first photo, and we see a third option for the user as well. The user can download these photos by just right clicking and saving the image itself. So this is our entire KGInPaint dashboard. There are few basic features like that. You can pan the scene graph itself, you can zoom in, zoom out on it. You can do the same on the input image as well, highlight the relationships, and of course InPaint, wherein you can replace based on your prompt, or you can remove the object itself. And thus we present KGInPaint.